In this video, we'll be learning long division and synthetic division and check the zeros of a function. Long division and synthetic division. To divide 3x to the 4 minus 5x squared plus 7x minus 9 by 2x minus 4. The expression 3x to the 4 minus 5x squared plus 7x minus 9 is called the dividend. The expression 2x minus 4 is known as the divisor. Let's have foundation check. If I have 3x to the 4, which is the leading term of my dividend, and 2x minus 4 is from here the leading term is 2x. So we just want to see if I can simplify this. So you know that you cannot divide 3 by 2, keep it as it is, 3 over 2. X to the 4 over x gives me x to the 3. Now I want to see if I distribute 3 over 2x to the 3 to 2x minus 4, how do we get the answer? Here 3x to the 4 minus 6x cubed. So we are using synthetic division. Divide 2x to the 3 minus 5x plus 4, which is our dividend in this case, by the divisor x minus 2. Since we have a term missing here, cube and then square is missing, so I want to write like 2x to the 3 plus 0x squared minus 5x plus 4. So this is our dividend. And put all the coefficients below here. So first you have 2, then you have a 0, negative 5 and 4, put it here. And then take the opposite sign of this one here. Negative 2 will come out as a 2 outside. And then the synthetic division format is pull this 2 down here. Then multiply these 2 with these 2. So you get a 4, write it there. Add 0 and 4. You get a 4. Multiply this 4 by 2 and write it here. So you get 8. So negative 5 plus 8 gives you 3. Same way, 3 times 2 is 6. Add them. You get a 10. So this 10 is my remainder. And since we are dividing cubic polynomial by a linear polynomial, so my quotient will be just 1 degree less. So it will be 2x squared plus 4x plus 3. The quotient and remainder form altogether in rational form can be written as this. When you divide the dividend by the divisor, so you can just write the quotient plus the remainder over the divisor. We'll use long division now. So you're writing that way, and the dividend divisor x minus 2 outside. So with the foundation check, you understand, take the leading term from the dividend and the divisor. Simplify. You get 2x squared. Now this 2x squared should be distributed to the divisor. So I get 2x to the 3 minus 4x squared. Now this ratio here I have 2x squared will go here, and then this term will go just below this. So let us write that way. 2x squared and then 2x to the 3 minus 4x squared. You need to subtract, so I just change the sign and then add. So the leading term will cancel out. So 0x squared plus 4x squared will give you 4x squared, and pull other terms, negative 5x plus 4. Leading term is 4x squared divided by x. So you get 4x. Then distribute this 4x to the divisor again. You get 4x squared minus 8x. Write that way. Again subtract or change sign, then add. So you have negative 5x plus 8x will give you 3x, and pull your 4. Continue this process. Leading term is 3x divided by leading term x in the divisor. That gives you 3. Distribute this 3 to the divisor, x minus 2. So you get 3x minus 6, and write it this way. So distribute 3, so you get x 3 times x minus 2 gives you 3x minus 6. So write the same way, 3 in the quotient form, and then 3x minus 6 below here. Change the sign, then you need to add. So 4 plus 6 will give you 10. That was expected, that we have found in synthetic division. So my remainder is 10, and the quotient we have 2x squared plus 4x plus 3. So we have used our synthetic division and long division to verify our answer. So the synthetic division is very limited. When your divisor is linear, then only you can use synthetic division. But remainder theorem and factor theorem. If you divide a polynomial f of x by x minus a, the remainder is simply f of a. So meaning is you just replace your x value in the function by a, you get a remainder. If the remainder is 0, then x minus a is a factor. Example. Show that x plus 4 is a factor of this polynomial. So in this case, identify your a. Clearly you can see your a is negative 4. So then evaluate the function at negative 4. And take your calculator and simplify this one, you get a 0. So then what we can say? X plus 4 is a factor of the function. Okay. Next one is find the remainder when 2x to the 3 minus 5x squared plus 3x plus 2 is divided by x minus 2. So by the definition we know, or the theorem we know, the remainder will be just simply f2. So let me call the expression as a function of x, and we are replacing x by 2. So f2 gives me 4. So I say that when I divide 2x to the 3 minus 5x squared plus 3x plus 2 by x minus 2, my remainder will be 4. So without synthetic division or long division, you can find your remainder. So this is for you. Test if x minus 2 is a factor of 2x cubed minus 5x squared plus 3x minus 2. Polynomial from zeros. If the zeros of a cubic polynomial are 2, negative 3, 5, you need to find the polynomial in factor form. Remember, we said factor form. So just write like x equals 2, x equals negative 3, x equals 5. Those are the given zeros. And then the factor will be x minus 2, x plus 3, and x minus 5. And then write the polynomial. Multiply all of them together. That's your polynomial in factor form. Find a polynomial of degree 4 with a 0, 1 of multiplicity 2, a 0, 2, and a 0, 3. Leading coefficient is 3. Write the polynomial with real coefficients. Also write the power function. So let us have a look on this. Look at that. We have said the leading coefficient is 3. So leading coefficient is 3. So we put this 3 here. And then we are saying that my 0 is 1 of multiplicity 2. So then we say x minus 1 and square 2. Or just f of x. The polynomial is. So we write the polynomial now. Since I have a 0, 1 of multiplicity 2, so the factor will be just x minus 1 exponent 2. So that we write here. X minus 1 is squared because multiplicity 2. Then you have 2 is a 0, so x minus 2 is a factor. 3 is a 0, so x minus 3 is a factor. And the leading coefficient is 3, so we write in front here 3. Now you just need to FOIL and simplify. So first you FOIL x minus 1 is squared, which will give you x squared minus 2x plus 1. And then also x minus 2 times x minus 3. When you use the FOIL, you get x squared minus 5x plus 6. And then FOIL it back again. So you will get all these terms. Simplify all of them, distribute 3. So this is your 4th degree polynomial. The power function of this polynomial will be just the leading term. Let's say 3x to the 4. Complex zeros. If x equals ai or ia is an imaginary or complex zero, then the complex conjugate will be x equals minus ai or minus ia. And then multiply them together. X minus ai, x plus ai. When you FOIL it, you will see your answer is x squared plus a squared. It is good to remember that if you have complex like this, so you can just square this and square this with a plus sign. Find a cubic polynomial with a real 0, 5 and a complex 0, 3i. So you can understand that x equals 5 x equals 3i and x equals negative 3i. These are my zeros. So then the factor will be x minus 5, x minus 3i, x plus 3i. So first we will work with x minus 3i and x plus 3i. So you can see x minus 3i, x plus 3i will be simply x squared plus 3 squared, which is x squared plus 9, and then again distribute x minus 5. So first you distribute x, you get x to the 3 plus 9x. Then distribute negative 5, you get negative 5x squared minus 45. You are done. We have another form, little complicated. A quadratic function has a complex 0, 2 minus 3i. Find the function with real coefficients. It is quadratic, so I have two zeros. So you can write as follows. X equals 2 minus 3i is a 0. So another 0 for sure will be 2 plus 3i. You just replace your imaginary 3i with a negative to a positive and keep your 2 as it is. So the factors are x minus 2 plus 3i from here. So you can subtract 2 and add 3i. So you get x minus 2 plus 3i. Same way you get here. Now multiply them together to get your function. You need to FOIL it, or you can just use the real part. In this problem, my real part is x minus 2. X minus 2, I can square them and then plus 3 squared. And then x minus 2 squared you distribute. You get x squared minus 4x plus 4 and then plus 9. So that gives you x squared minus 4x plus 13. Finding zeros. So we are just saying that you are given a cubic function, f of x is x to the 3 plus x minus 10, and 2 is a 0 of this function. So you need to find remaining zeros. You can apply synthetic division. So you have 1. The second square term is missing, so I put a 0. And then you're going to divide by 2, which is a 0. And write the form. Pull your 1 here, multiply by 2. Add, again multiply by 2. Add, again multiply by 2. So as expected, remainder should be 0. So 2 is a 0. Now what is our quotient? X squared plus 2x plus 5, and I want to solve this one to get other zeros. So this is a quadratic function, and you cannot factor this, so apply the quadratic formula. Like the values there, simplify. So you get these answers. Now you can distribute 2 in the numerator. So negative 2 over 2 will give you negative 1, plus or minus 4 over 2 will give you 2, so it's 2i. Another example. The function f of x equals x to the 4 plus 3x squared minus 4 has an imaginary 0, negative 2i. Find other 3 zeros. So for sure another 0 we know, which is 2i. Because the given one is negative 2i, so the conjugate will be positive 2i. Then you can write x minus 2i, x plus 2i. This will be a factor of this polynomial. And then you simplify as before. You get x squared, and then 2 squared will be 4. So this must divide the given polynomial. So use the long division to divide it. Remember the mastery check or the foundation check. So x to the 4 will divide by x squared. We get x squared. Write it there. And now x squared should be distributed on x squared plus 4 to get it x to the 4 plus 4x squared. Change sign, add them. Negative x squared, negative 4. Now same way, leading term is negative x squared. You're going to divide by x squared. You get negative 1. So put it here. And then distribute negative 1 to the divisor x squared plus 4 to get negative x squared, negative 4. So the remainder is 0. So now we have got x squared minus 1 will be our quotient to solve. So when you solve this one, you get x equals plus or minus 1. So you have got all 3 zeros. Negative 2i was given. So you have got 1 0 is 2i, complex 0. And the other 2 zeros are 1 and negative 1. Thank you for watching this video.